Hello, I'm Don MACHHOLZ, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 26 for the week of July 1st, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. What's up in the sky this week? As our week begins on Wednesday, July 1st, the moon is bright and in our southern evening sky. On July 5th and 6th, the moon passes south of first Jupiter, then Saturn. By next Tuesday, July 7th, the moon will be in our morning sky and still very bright. This is a good week for photographing the moonrise. The moon has a lunar eclipse dipping into the outer portion of the Earth's shadow on July 4th and 5th, with the center of the eclipse being on July 5th, 04:43 Universal Time. That translates to the morning of July 5th in Africa and the evening of Saturday, July 4th for most of the Western Hemisphere. This is known as a penumbral lunar eclipse, where the moon will dim slightly. You'll notice it if you're looking for it. Most others will not. Anyone who can see the moon on the night of July 4th and 5th while it is in eclipse can see the eclipsed moon. The total eclipse lasts about 2.5 hours. The whole eclipse, start to finish, is visible in Western Africa on the morning of July 5th and Antarctica. And also, all of the eclipse will be visible in South America on the evening of July 4th and parts of North America. Which parts? All of Mexico and the eastern 80% of the United States and the eastern half of Canada. They will see all of it. Western Europe and most of Africa will see the beginning of the eclipse near moonset on the morning of July 5th. But the moon will set before the end of the eclipse. The remainder of the U.S. and Canada will see the end of the eclipse sometime after moonrise on July 4th. As said, this is a penumbral eclipse. The moon goes through the southern part of the Earth's outer shadow, and so the northern part of the moon will get a slight shading. As eclipses go, this one is rather wimpy and will be difficult to notice. On July 4th, the sun is at aphelion. That's when it's furthest from us. The Earth does not go around the sun in a perfect circle. The shape of our orbit is an ellipse, a slightly squashed circle with one end closer to the sun than the other. The difference between our closest point to the sun and our most distant point is only 3.5%. Generally, this is not noticeable. In early January, we're at our closest to the sun. In early July of each year, we're at our most distant point. This also means that the Earth's speed around the sun is not constant, and presently we're going our slowest of the year. You won't feel the difference, but this change of speed is reflected in part in something known as the equation of time. From our perspective, the sun seems to speed up or slow down. You've probably seen the figure 8 on globes of the Earth. Both the varying speed of the Earth and the tilt of the Earth's axis contribute to those adjustments. With the sun further away, why is it summer and therefore hotter in the northern hemisphere? That is because the sun is far north of the equator. It's in the sky for a larger number of hours, perhaps 14 hours instead of the 10 hours we get in the winter. And also, right now, it is higher in the sky, meaning the sunlight is more direct upon the land, warming it more. The winter and summer have nothing to do with how far we are from the sun. Will you be able to see the International Space Station this week? If you live north of 50 degrees north, then it will be visible beginning July 2nd or 3rd, and it will be in your morning sky. Between about 30 and 50 degrees north, the ISS will be in your morning sky, sometimes twice on some mornings. Chicago, Turkey, Japan, that is you. From 30 degrees north to 25 degrees south, the equatorial zone, you will not be able to see it at all. India, Chad, Peru, not this week. From 25 degrees south to 40 degrees south, it will be in your evening sky, but only toward the end of the week, July 5th through 7th. You will be able to see the International Space Station in your evening sky. That's Australia, South Africa, that's you. New Zealand at minus 45 degrees will see it in their evening sky, sometimes twice per night. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. The traveling astronomer. I suppose in the ideal situation, you would live where the skies are dark and low horizons and clear weather most of the time. But life does not always allow you this ideal situation, and we all have priorities, such as raising a family or being near our employment, our extended family and social centers. That is how life is. I understand that. For me, I began my astronomy endeavor in my parents' backyard in Concord, California in the mid-1960s. That was my setting for the first 6 years. That was all I knew. I was then in the U.S. Army from 1971 through 1974 and traveled a bit, most of the time with binoculars and later with both a 4.5-inch reflector and a 6-inch reflector telescope. But then back to the backyard in Concord, California. That's where I began my comet hunting program in early 1975, and within 10 months, I had bought the mirror and built around it a 10-inch f3.8 reflector telescope to replace the 4.25-inch f5 reflector I was using. Going from a 4.25-inch to a 10-inch reflector would gather more light, more than 4 times more light. So those faint fuzzy objects should appear easier to see, right? Wrong. It did not take me long to discover that the larger aperture gathered more light, but the shorter focal length brightened the field enough so that the contrast was reduced and I could not see as well as I could with the smaller scope. Concord, California had a population of about 40,000 at that time, and the light pollution was competing with the faint fuzzy objects in the telescope. So I became a traveling astronomer. I packed up the telescope and traveled 4 miles north to Clyde and set up along the road. That did the trick. I was now able to see some faint stuff in the 10-inch telescope. An even darker sight was the Concord Pavilion. While it was still being built, I set up in the parking lot in the early morning hours. Then I set up in an undeveloped subdivision nearby. The roads were in place and paved, but no houses and no streetlights. These were the places from where I comet hunted from the fall of 1975 to the spring of 1976. In podcast 15, I discussed how I found Loma Prieta in the Santa Cruz Mountains. You might want to listen to that episode, number 15. But to suffice to say, I found it by driving around at night and going higher and higher to get above the fog. And I landed at Loma Prieta, a location from which I comet hunted for 15 years, 1,600 sessions, 4,000 hours, 3 comet discoveries, and several early Messier marathons. In Colfax, California, where I lived for nearly 30 years, and here in Stargazer, Arizona, I do not need to commute to enjoy astronomy. I do it from my backyard. But many cannot, and they need to commute to their observing sites. This often limits observing to weekends. And when I made a trip to the New England states in 2005, I first realized how important those trips are to the amateur astronomer. Imagine you have a large telescope, and you can only use it on moonless, clear sky weekends. And to do that, you have to travel 50 to 200 miles and make a weekend of it. These amateur astronomers must work very hard to have observable skies, something most of us take for granted. They certainly have my respect. Even out west, amateur astronomers in Phoenix, San Diego, Los Angeles, San Jose, Sacramento, San Francisco, Portland, Seattle, they all have to commute to darker skies to do much of their astronomy, even in Fresno. A few ideas I'd like to pass along. First off, not all astronomy needs dark skies and low horizons. Lunar and planetary observing and imaging can be done from the city. I have seen many good lunar and planetary images taken from someone's balcony. I'm not making this up. Who would think that you can do astronomy from your balcony? But you can, and many do. Double stars, planetary nebula, even some galaxies and comets. When I lived in San Jose, I lived in the suburbs. We still had sizable light pollution. In the late 1980s, I experimented with my 10-inch f3.8 comet hunting telescope, and I did some comet hunting along the meridian on a specially designed mount with a Barlow lens, and I was able to reach magnitude 12 for fuzzy objects. Before you pack up and leave, see what you can do from where you live. Those solar astronomers have it made. And dark sky imaging is easier than visual observing in light-polluted areas. The imagers can filter out light pollution, take many images and stack them to increase contrast, and image over several nights. For those having to leave town, it helps to have a van, pickup truck, station wagon, remember those, large enough to carry your instrument. My 10-inch f3.8 reflector fit in the back seat of my Ford Maverick. I made a cradle for it that cushioned it a bit from bumps. An automobile with a fold-down back seat also provides a lot more room. I have seen some astronomers buying a small trailer, much less expensive than a motorized vehicle, and outfitting that trailer with all of their astronomy equipment, including a telescope or two. Then just hook it up and go. For Dobsonian telescopes, you might want to remove the optical tube from the cradle and/or remove the primary mirror from the tube and wrap it separately. This takes only a couple of minutes to do and can save your mirror from being ruined. Where to go? Away from civilization. Get on the freeway and head to a darker sky location. Dark sky and light pollution maps are available for free on the internet. Check it out and see where the dark skies are located. Your local astronomy club may have a site or two, private or public, where they conduct dark sky star parties. If you have a friend or relative who lives in the dark, so to speak, see if you can go to their property and set up. County parks work well if you do not need to leave an hour after sunset. Wherever you go, make sure you are legal and stay safe. Next week, I'll discuss amateur observatories. A couple of comets remain in our evening sky, with the moon being out of our evening sky at the end of the week. That would be a good time to get out and see how they are doing. Both are plotted on Podcast 26, Map 1, and the position for all three comets mentioned this week are available on Podcast 22, Comet Positions. Comet Pan-STARRS 2017 T2 remains at magnitude 9 and is headed slowly south. Comet 2019 U6 Lemon is about magnitude 6 for both the northern and southern hemispheres. You'll find it low in your western sky at evening twilight. From the northern hemisphere, with each passing night, it climbs more than a degree higher in the sky. South of Leo, it is slowly moving north, and in a couple weeks it will be passing a lot of galaxies in the constellation Virgo. That brings us to Comet 2020 F3 Neowise. For the past week, it's been in the SOHO images and hanging in there at about magnitude 2.5. But we are not out of the woods yet, as on July 4th, it reaches its closest point to the Sun, 3 times closer than we are. The heat is on. Will it survive? Our fizzle and the sizzle. Before moving into our northern evening sky in mid-July, the comet Neowise makes a brief appearance in our northern morning sky. And the further north you live, the better the conditions to observe it. Podcast 26, Map 3, shows the northern eastern sky with Comet Neowise plotted for the next 2 weeks. If it behaves normally, it will be brightest on July 4th and slowly dim from then. However, it will also be moving into darker skies as it moves further from the Sun as seen from the Earth, and with the darker background may be an impressive sight. Let's learn a new constellation. Cygnus the Swan, also known as the Northern Cross, is in the northern hemisphere and visible in the northeastern sky as the sky darkens. This is one constellation where the shape looks like the name. This is a swan flying southward. A long neck and a body with 2 wings, or a cross. Either works. The brightest star in Cygnus is Deneb, a superluminous star that is about 1,600 light years away and about 200 times larger than our Sun. It appears blue due to its hot temperature. It looks good in binoculars and a telescope, so give it a try. The northern summer Milky Way runs through Cygnus and is home to 2 Messier objects, both open star clusters, M29 and M39. This week we will be looking at M29. More about that later. If you have dark skies, you can see the Milky Way running through Cygnus. Look carefully at it and you might see the Milky Way seems to split into 2 as it runs southward. This split continues through the next couple of constellations. It is called the Great Rift, and it is caused by dust and gas between us and the stars of the Milky Way. The constellation Cygnus deserves time spent scanning with binoculars. Look at all the stars in various concentrations, some bunched here, some bunched there, and the dark areas scattered throughout the area. This is a very impressive place to observe with binoculars. M29 is a small open star cluster just south of the middle star in Cygnus. It is identified on Podcast 26, Map 2. M29 consists of only about a dozen stars, and it is far away for an open star cluster, about 6,000 light years away. Through the binoculars, it will appear as a small fuzzy object. It has at least 7 stars and as many as a dozen. And those 7 main stars form a box and a handle, something like the Pleiades or a small, very small dipper. We show this at public star parties, and one, and only one person, said it was the most impressive object she saw that night. Okay, one person gave a 5-star rating for a 7-star cluster. We'll take what we get. Note in binoculars the area around M29, very impressive. In the telescope, the shape of M29 is more readily visible, as are some of the additional stars. In the large telescope, you can see about a dozen stars. You have been listening to Looking Up with Don, podcast episode number 26 for July 1st, 2020. I'm Don MACHHOLZ. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky, we'll continue observations of Comet Neowise, learn yet another constellation, and I'll talk about amateur astronomical observatories. Thank you for listening. See the sky this week. I'll see you next week.